Okay, let's take a look at a composition involving a graph. So what we have is a graph, and on that graph are actually two different functions. We have the red function, his name is g of x, and then we have the blue function, her name is f of x. And then using those two functions, we have four questions down here that we are going to answer. Okay, so the first one says f of g of 5. All right, so like all compositions, we're going to work this from the inside out. I can't figure out f of anything until I first know what g of 5 is. So let's start there. So g of 5 is where we'll begin. Now, what does that mean? G of 5 means that you are inputting, notice inside parentheses, inputting the number 5 for the function named g. So since we're working with a graph, I'll be looking on the x-axis input of 5. Um, and once I locate an input of 5, I'm looking specifically for who that pairs with on the red function named g. And it just so happens it's actually on the x-axis. An input of 5 pairs with 0. That ordered pair right there is 5, comma 0. So when you input 5 for the function named g, you get 0. So g of 5 is 0. Now, here's where the composition comes into play. Once you know that the output for that initial step is 0, you're then going to take that output of 0 and plug it in for the next function, which in this case happens to be f. So now we're going to do f of 0 and follow through with this composition. So once I plug in f of 0, now 0 is the input for the function named f. So I'm looking at an input value of 0, that would be right here. And then once you get to an input value of 0, you're purposefully wanting to pair it with the blue function. And you'll notice the blue function is down here at -1. So f of 0 is -1. So that is that statement. F of 0 is -1. And that's it. That is the composition. So the final answer, so to speak, is just that f of g of 5 is -1. That's our final answer. Okay, good. Moving on to part B. G of f of -2. Okay, so starting with f of -2. So -2 is the input value inside parentheses. So I'm looking for an input of -2 on the x-axis. And once I get there, I'm purposefully wanting to pair it with the blue function named f. And you'll see that the blue function pairs with an output of 5. So f of -2 is 5. Now, once you have that value, it's an output value for now, but then you take that output value and it becomes the input to the next function whose name happens to be g. So now we're going to do g of 5. And oh, we had to do this one a second ago. So now we're going to be using 5 as the input again. So 5 on the x-axis. And once you identify 5 on the x-axis, you're looking for the red function. And just like before, you'll notice it's right there. It's at the x-axis. So the final answer here is 0. And so if you wanted to like fully notationalize, so to speak, what you just found, g of f of -2 is 0. Final answer. Okay, moving on to part C, g of 4. All right, so we are going to start with g of 4. And in order to answer that, I'm going to look for the input value of 4 on the x-axis. And once I locate that, I'm going to pair it with the function named g. All right, so let's estimate this. It's not going to be perfect. I feel like that's definitely past the halfway point. So maybe like 5.7-ish. I feel like it's past the halfway mark. Let's go 5.7. Certainly, anytime that you're using a graph, you may find yourself estimating, and that is okay, guys. So we're going to go 5.7 as our approximate answer there. And now that I have the 5.7, I'm going to use that 5.7 and plug it in to the next creature. Well, guess what? The next creature is also G again. So now we're just going to go back to G and we're going to use 5.7 as the input this time. So now I'm looking for 5.7 on the x-axis. And once I identify where that is, I'm going to do my best to pair it. I kind of feel like it's around -10. I'm not saying it's perfect here, guys, but I'm thinking around -10. So let's go with that, around -10. So, final answer is that G of 4 is about -10. Okay, good. And then last but not least, we've got another composition, this time involving an inverse. Ooh, that'll be fun. So G inverse of f of 1. So this one starts with f of 1. So starting with f of 1. So the input value in parentheses is 1. So I'm looking on the x-axis for a value of 1. And once you do, you're pairing it with the function named f, the blue guy, and you get about -4. So f of 1 is -4. But then here's where the composition comes into play. You're now going to take that -4 and you're going to plug it in to the next creature. Well, it just so happens the next creature is G inverse. So we are now going to be doing G inverse of -4. And since we have inverse notation, okay, so don't get me wrong, -4 is inside parentheses. It's technically an input. However, it's the input to this guy called inverse. Okay, well, I don't have a graph called inverse. I only have a graph called regular G. And so for that reason, we're going to be forced to apply the reversibility of inverses. And that is that if -4 is meant to be the input of the inverse, then it should also be identified as the output of the original G function. See, now that's helpful because I do have the original G function. So if I look for an output of -4, and I now want to pair it with the G function, which is the red guy, okay, so output of -4, who does it pair with? Well, it pairs back here, it pairs over here, and it pairs again over there. See, the inverse of G is clearly not a function. It does not pass the horizontal line test. So there's more than one answer, and that's okay. We're just going to write down all of the answers. So if I pair -4, it pairs with right there, and again right there. So let's estimate all of those values. We would have negative, what's that one far to the left? Maybe about -2 point, let's go maybe -2.7. And then the one in the middle, I'm going to call that not quite the halfway point. Let's go maybe 1 point, let's do 1.4 maybe for that one. And then on the far right, what do we have there? 5 point something. Once again, not the halfway point. Let's go maybe 5.3. So we've got -2.7 approximately, 1.4 approximately, and 5.3 approximately. And all three of those are the final answer. Okay. Nice little review of inverse functions. I like how that's showing up at the end of our semester. Perfectly timed, in my opinion. All right. Hopefully that's helpful, and we will be in touch.